regardless. Okay, so you should have this in front of you. You have dealt with these equations before. Do any of them look familiar?
A little, maybe. Yeah.
No.
These two, this one maybe? None of them?
That says perfect.
But these ones too?
Yeah.
And they have rough decay.
They should look a little familiar. So the reason that we are doing them now, like you've done them in the past because you are fully capable of plugging numbers in for P and for R and T and just seeing what your answer is. And you've done that before. You should have done that before. The reason we're doing them in this unit is because now it's appropriate for us to solve for T. You never knew how to solve for T before, now we do. How do we get a T that's an exponent that is a variable? How do we get that alone? Not square root, because it's a variable. We're gonna have to do logs. So this is the first time you could have ever used the log to solve a question like this because you've never known about logs before, but now you do. So that's the reason we're coming back to these formulas that maybe you've seen before, but you couldn't solve it in this particular circumstance. Now we're going to be able to do that. So the Y stands for the final amount. Typically, these questions have to do with money, so they're talking about banks and interest and stuff like that. Yep, the final amount or the total amount. The R is the rate. The R is the rate. And it is always written as a decimal. So if you have 5%, how do you write 5% as a decimal? 0.5. Not 0.5, 0.05. Good. If you have 2.5%, I know it's a decimal already, but if we write the percentage as a decimal, then what would the percentage be as a decimal? 0.025. So basically the trick to this is you take the decimal point from the original number and you move it to the left twice. Yep. So if we had 10%, what is 10% written as a decimal?
0.001.
0.10. 0.10. Because the decimal point would have been after the 10, and when we move it 2 places to the left, it goes right before the 1. So we just take the decimal point and we move it 2 places to the left. Right. The exponent T is time. And the time is typically in years. Most problems will be in years. Every so often they say like months or days, and you'll know like the whole problem is in months or the whole problem is in days. But typically they'll start talking about months in the year. So typically we will use years. All right, the P is the initial value. They use P because it means principal, but most of us don't say principal when we mean a starting number. But P is the initial value or the starting value. The E, if you guys see the E right there, that is a button on your calculator, right? We've been using that so far.
E is a button.
Yep. It is not a variable. There's nothing to plug in for E. It is a button on your calculator. All right. The N value, you can see it in 2 places. N only shows up in one of the equations, but it shows up in 2 places in that equation. And the N means number of times per year. So if they said daily, how many times per year is that? 365. If they say weekly. Weekly is the next biggest one. I like to have these in order. If they say weekly, how many times per year is that?
52.
52, good. If they say monthly, it's 12. 7 days in a month, but 12 months in a year.
Huh?
Quarterly. It'd be every 3 months. A quarter is 4 times a year, right? Quarters, there's 4 in a dollar, so there's 4 quarters in a year. Anyone know what semi-annually is? It's 2, twice a year. What about annually? Once. Okay. Yeah, they should be familiar because you could have worked with these equations before. You just haven't solved for t before. That's a different variable than you should have been able to solve for in the past. And then in half-life, you might have worked with that if you've taken chemistry. In chemistry, they use a different looking equation for half-life, but these equations, they find the same numbers, they just look different. So T, again, is time, typically in years. H is how long a half-life is. All right, we're going to do a couple example problems. You could write them on the back of these notes if you want, or you could do them on a separate sheet of paper. It's up to you. If you need notebook paper, there's some in the back. You can do it on the back of this sheet, or you could do them on separate paper.
Easy said than done.
That's not what you use.
All right. These are word problems. These are word problems. So stretch out your hands. We're about to write. All right. Yep. Perfect. Sam invests $7,500. You guys ready? At 7.75% interest. Don't put a period, there's more than that sentence. And his interest is compounded quarterly. How much will he have after 3 years? So the first thing we need to do is we need to figure out what equation we are using. There's a word compound in there. That word is important. We have 2 equations that use the word compound. We have compound interest and compounded continuously. We're going to use compound interest, and the reason we're using that one is because they gave us an n value, and this is the only equation that has an n value. They said compounded quarterly. So when you look for this one, you know that you're going to have compound interest if they say the word compound and they give you some sort of n to plug in. That's important. All right? That's a good indicator. That's the equation you're using. So first things first, we're going to write down the equation that we're going to use. Y equals P times 1 plus R over N to the NT. And then we want to figure out what each of our variables is. So y is the final amount. Did they tell us what the final amount is?
No.
No, that's actually what we're trying to find. So y is question mark, we don't know that yet. P is the initial value or the starting amount.
7,500.
Right? That's just the number one. R is the percentage written as a decimal.
7.75.
So 7.75%, but when we write it as a decimal, how do we write it? 0.0775. So we take that decimal place right here and we move it twice to the left. N, it said compounded quarterly. 4. And then T, how many years?
Quarterly, so
3 years.
like
It's in 3 years. T is 3 years.
also quarterly.
So we're going to say y equals 7,500 and then 1 plus 0.0775 over 4 to the 4 times 3. This is not a Math 3 question. You could have handled this question back in Math 2 or Math 1. So this is just they gave you the numbers, you plug them straight in, you get your answer.
I think I'll do this a little.
So pretty much saying out all, like, we're giving got enough all the information for how we're using y equals in this case is what we're using. And it'll be different every time.
It'll be different every time. There's a lot of times these problems for you guys are either going to be you're solving for y, and that's just plugging numbers in. You're not doing Math 3 level work, or you're solving for t, and that's the Math 3 level problem. All right, so y equals. We're talking money here, so I'm going to do only 2 decimal places because cents. And then these are story problems, so how do we answer story problems? In full sentences. In full sentences. You have 2 choices. You can put the dollar sign in the front, or you can skip the dollar sign and write the word dollars after.
Dollars.
Yep.
I'll tell you guys.
No, you got both options. Please don't put a dollar sign after the number. That's weird. We don't write it like that. That's like not a thing.
After
You can write a dollar sign in the front, or if you don't want to write the dollar sign in the front, you can write the word dollars after the number. So it's important we make sure that our units. It's important we make sure that our units are part of our answer, and the units here are dollars. All right, next example problem. How long
type 1.
until he has $15,000? That's the question. How long until he has $15,000? Yeah.
If you wanted to use
You could use the table. That would be using the cheater Math 1 method. Yes. All right. So here we're using the same equation because it's still the same situation. So we still have y equals p times 1 plus r over n to the nt. We're still doing that. So we want to find our variables again. So this time it says how long until he has 15,000. Do we know what the end number should be?
Yes.
We do.
Oh, yeah.
It's 15,000, right? That's what our goal is. Do we know what the initial amount is?
Yes.
Yep, it's still 7,500. That hasn't changed. That's what he started with. Do we know what the rate is?
Yep.
Yep, that's still the same, 0.0775. Do we know how many times it's compounded each year?
Yes.
Yep, we still know it's still quarterly, right? Do we know how many years? No, that's what we're solving for this time. That was a bad looking question mark. All right. So let's plug all these numbers in. We've got 15,000 equals 7,500 times 1 plus 0.0775 over 4 to the 4p. All right. So we want to start moving stuff away from t. What could we easily move away from t?
75.
The 7,500 we could easily move. This 4 right here is trapped with the t as an exponent. It's trapped up there. The parentheses you can't get inside very easily. But this right here is being multiplied. It's really easy to divide it over. So we're going to go ahead and divide by 7,500.
You divide it?
Yep.
Subtract it?
Nope, because it's multiplied. So the opposite of multiply is divide. So 1,500 divided by 7,500. 2. All right, now with this part right here, we can simplify what's in the parentheses, but we can only write it if it ends up being like a nice decimal. I don't know that it does. 0.0775 divided by 4. So we can simplify inside the parentheses if you guys want to write all those decimal places every time. Would you rather write the fraction version?
Yeah.
Are we okay with that? Or we can just leave it like this. How do you guys want to write it? Just leave it? Okay. So at this point, this is the exponential form of the problem. We have something trapped in the exponent, and we want the exponent to be solved for. So we have to undo these parentheses.
Okay, would you do log?
We have to do log now. What is the base of the log?
E?
Nope.
1, 4,
10,
1, 2,
12.
3.
The whole thing. Remember? The base becomes the base. This right here, this is the base of the exponent. The base of the exponent is what becomes the base of the log. So it's a nasty looking base. I'll show you guys in a second how we can plug that in our calculators, okay?
How did you get rid of it? It's just you.
So it's log base mess of 2. Because we start with the base and then go to the other side of the equal sign. So of 2 equals 4t. But do you see how now that we've done that, our t is almost alone?
Yeah. And then you just have to divide by 4.
And then we take that whole mess and we divide it by 4.
Oh my goodness. That's too much.
So it's exactly what you guys did yesterday. These problems just don't look nice. They look worse. The nice thing about these problems are they consistently look this way, so it's confusing the first couple times and you get kind of used to it.
That seems pretty good.
So we're going to go ahead and type this in. I've got the top of the fraction and I've got the bottom of the fraction, so I'm going to hit alpha y equals to type it in. I'm going to do math up, and then you're going to do log 2 divided by log mess. That's what you're going to do, right? We are going to plug the mess in as our base, so I'm going to put a parenthesis in and then 1 plus 0.0775 divided by 4, and see, your calculator is totally fine with that base.
We don't have to put it over or anything again. The fraction is on the inside.
You can put a fraction for the 0.0775 over 4 if you want. But your calculator is totally fine with that base. It doesn't have an issue. So t is approximately And we'll go ahead. I think on the assignment I said to just do 2 decimal places for the whole assignment just to be consistent. So Abby, for you, you're going to type in log 2 divided by log 1 plus 0.0775 divided by 4. And then you're going to take that whole answer and divide that whole answer by 4.
She got a different answer. So it'll take them approximately 9 years.
Yep.
You wouldn't have to say 9 years and 3 months or 9 years and 3 days.
No, I'm not gonna make you convert it.
Okay.
I'm just gonna have you say it would take approximately 9.03 years to live that. Good question. All right, it would take
Just said
it would take about 9.03 years to save $15,000. We're gonna do another example.
oh no.
Oh no! All right. You might have to get a sheet of paper.
Is this the last one that we're going to do?
It's the last one, and it's a 2-parter, just like the last one was.
2-parter.
2-parter.
Sarah.
I know we're about to spend more, but we don't have work.
Sarah.
No school, that means no school. That's how they get.
So Sarah deposits $1,000 in an account paying 3.8% interest compounded continuously. How much? It's right up here.
Who's Sarah? Did she go here? Is she cute? I can still ask.
Ooh.
How much did they say?
She deposits $1,000 in an account
Wish I had $1.
paying 3.8% interest. And it is compounded continuously.
After we finish this video, can we turn the AC on? Oh, yeah.
White was perfect.
Yep. So there's always some keywords in the problem that will help you recognize the equation, or if the keywords are missing, then you can kind of deduce that it's one of the other equations. So here, when it says the words compounded continuously, we automatically know it's the PERT. That's what people call it. We know it's PERT. So it said that wording, compounded continuously, so we know that it's PERT.
Sounds like a sick rhyme, bro.
All right, so do we know the final amount? Nope, that's what we're trying to find, right? Do we have to find something for E?
No, that's
No,
not
that's
one.
a button on your calculator. What is the R value?
3.8.
It's 3.8, but we have to write it as a decimal, right? 0.038, okay. And what's T? 5. So we're going to write y equals, oh, I forgot the P.
I'm about to say.
What's the starting amount? 1,000. Okay. So we're going to say 1,000 e to the 0.038 times 5. Yeah, these are the ones I was saying. These are not Math 3 level. These are Math 1 or Math 2 level, depending on when it shows up. E is Euler's number. It stands for 2.71.
Wheelers.
How do you get E on the calculator?
E is second ln.
Oh, so I need to run
One term.
And
120. 121.
So Sarah has $1,209.25 after 5 years.
before and after. Just write it backwards. Oh, write it upside down.
That's the part one, don't we have?
Yep. We got one more part. We're going to solve for the t. We're going to have to do logs. So the next question is, how long will it take the account to double? Yeah.
2K.
So they were kind of weird about this one. They just said double.
2K.
You gotta figure out what double means.
Yeah. So we know what the end amount is. They just kind of made it secret. You got to think about it. So if you want your money to double, then how much money should it be?
2K.
2,000. Yeah. She started with 1,000. She wants it to double, so she wants 2,000. The p value is going to stay the same. That's going to stay 1,000. Is the r value going to change?
No.
No, still 0.038. Is the t value going to change?
Yeah.
Yeah, the question is how long, so that's what we don't know. How long is the thing we're solving for? So we're going to say y equals p times e to the r t.
Wait, why do we need the initial? Why do we need the initial step with
If you're going to plug in 2,000, you have to plug in 1,000. If you know it's doubling, you could say 2 and 1 right here. That would be fine. I could just have the smaller numbers. So our goal is to get to the t. What can we move away from t?
500,000.
1,000. How do we move the 1,000 away? Divide. So 2 equals e to the 0.038t. And next we want to get rid of the e, so we're going to ln. ln the right side, ln the left side. ln2 equals 0.038t. So why did this problem look so much nicer than the last one?
Because I got
It knows it's got
Yeah, the base was E instead of the base being the parentheses. That's why it looks so much nicer. Okay. All right, so ln2 equals 0.038t, and then how do we get t ln? Divide 0.038. Oh, don't put a dollar sign. That'd be weird. Years, not dollars. Yeah. Well, when you're making money off interest and not actually putting money in yourself, it takes a long time.